Our final electrophilic addition mechanism is with sulfuric acid, and this is the one that probably causes students most discomfort, and I think that's probably to do with the fact of how to represent sulfuric acid in this mechanism. Hopefully we know the formula for sulfuric acid, but do you know what an atom, a molecule of sulfuric acid looks like? So we have a sulfur doubly bonded to two oxygens and then it's also bonded to two OH groups. So there's our two hydrogens, our sulfur and our four oxygens. So try and remember the structure of a molecule of sulfuric acid. The next thing for us to do is try and decide which part of that molecule the alkene will be interested in. Remember, we're looking for something which is electron deficient to be an electrophile and to react with the carbon-carbon double bond. Well, hopefully we've picked this area of the molecule, and in particular we're looking at the hydrogen, which will be electron deficient, bonded to the oxygen. So what I tend to do when I'm doing my mechanisms, so I will show the area that I've highlighted in green like so, and then I want the rest of the sulfuric acid molecule. So we've got the sulfur and the two oxygens and then another OH group, and you'll often see that represented as SO2OH. If you really want, you can draw the sulfuric acid molecule out each time, but it's probably a little bit easier just to simplify it to that, and hopefully we can see those two things are the same. So I think that's the hard part done. So we're now able to draw our sulfuric acid molecule in the mechanism. We'll put the hydrogen, which is delta positive, approaching the carbon-carbon double bond, and now it's just curly arrow time. So the double bond breaks, forming a bond, so the carbon's forming a bond with the hydrogen, and then the hydrogen-oxygen bond breaks. Those electrons go into the oxygen. So note the carbon-carbon double bond has broken, and we've now just got a single bond between those two carbons. We've made a bond between one of those carbons and the hydrogen. So the bond between the hydrogen and the oxygen has broken. The electrons go into the oxygen, which means that this oxygen is negatively charged. Probably doesn't look very familiar there, although we might have seen that as a HSO4- ion, a hydrogen sulfate ion. The right-hand carbon is positively charged, so there's our carbocation, and we mustn't forget that we've got a lone pair on this oxygen there, and then to finish our mechanism we're going to form a bond between this oxygen and the positively charged carbon, giving that molecule as the product. This has made ethyl hydrogen sulfate, and probably what we'd want to do with that is to hydrolyse it with water to make the alcohol and get our sulfuric acid back.